yesterday we did something, so let me just do a recap very quickly and then go straight to the layout and then talk about the kit and then talk about the Arduino shape. So that is where we are. So straight to the Arduino itself. Of course, we say that Arduino is a physical programmable circuit board which is called a microcontroller. And then Arduino is not complete without the software, and that's where we are looking at the software. And the software is a platform that we use for coding. Generally, this is a platform that we use for us to be able to write our codes, and these codes are the ones we are able to upload to the board so that we are able to accomplish maybe some of the tasks that we plan to accomplish today. Great. So I'm taking you back to a bit of the layout of yesterday. I mentioned that there are probably Arduinos of different kinds, and I think I remember talking about the pins, and we talked about the pins being on both sides. But I wish to remember, I want you to have a look at the power pin. In the power pins, we have those different pins. This ground, two ground, written G and D. Remember the output of each pin. So if you are to connect any component to this pin, you must make sure that that component can be able to sustain the power output of 5 volts. If it is on this pin, then that component should be able to sustain that power, or else the component will burn, or rather will be spoiled. So we don't want situations where electricity burns this. Remember, this is about electricity, and you have to be very careful, and that's why it's very important that you take note of what is the output. But generally, all the other pins, like the digital pins, we are aware that most of them, the output is always 5 volts. So this is majorly the general one. Apart from this particular pin that produces 3.3 volts, the rest are basically 5 volts. All of them, they are able to bring out 5 volts. Then, of course, we have another reset here. Then I think I wanted to talk about this pin here. This pin here, it is for voltage in. It is voltage, so you can always see it is voltage in. I hope I'm going to write this well with the mouse. Voltage in. So, I mean, voltage is getting in. So this one, probably you have a project where you want to use power from a source like solar, and you want to package the whole of this thing and put it, probably your project, you package it together as maybe some sort of in plastic package, and you want it to be in the field using solar, and you want now the power input. Remember, we have said power should be getting in through the power in button here, the power in space here. But in case you don't have, this is basically the power which is being plugged from either a battery source or a wall and stuff like that. But in case you don't have this, please kindly ensure you just put voltage in via the voltage in. And this one can be very, very useful when you want to come up with a project that probably is using solar as your base for working. So think about that as particular parts. Probably if there's an echo, somebody says there's an echo. Thank you so much for giving me feedback. I'm expecting your feedback through the Q&A session, and probably also ensure you write in that section, ensure you're also indicating some questions that will be answered shortly. I want you also to look at probably which other pin. These analog pins, these ones, of course, are for analog either input, and remember, you are fixing the analog gadgets here, and some of the analog gadgets we'll be looking at them shortly from now as we continue today, of course. Then I want you to look at this particular. This is like the brain. Remember yesterday we were talking about this kind of the microchip. This is a chip controlling this other type of the board, and they are both the same. You can see they are all the same. The only difference is on that particular controller. And let me just probably change the color to red so that you're able to see. So I'm saying this other controller here, if you can look at it, this controller here, microcontroller, it's not the same as this other one that we are looking at, but they are both doing the same work. The difference is that in this other, the blue one here, this one is removable. You can remove it and put another one, but this one is basically put on the board, and you may not be able to remove it. So you'll find this variation of boards, and they are all Arduino boards. They are all Arduino boards, and they can do similar work. It's written, you see, programmed with Arduino. So it's basically an Arduino board. The manufacturer may be different. Don't worry about manufacturers, but all of them, they do similar work because you can see the number of pins are just similar, and also the way it is. The role and the functions are equally the same. And you can even see, I was talking about voltage in pin. Oh, sorry, it's here. And the voltage in pin, so that you're able to put in the pins to connect with external source of power. And especially here we are looking at the solar power in case you have a solar project. I think this is what we went through yesterday, and it's not bad to come again and look at it again and again. It is important that you understand the board, because if you don't understand the board, tomorrow you may not be able to do a project, and you may not be able to explain to somebody why the board and why are you using Arduino and what is all this about Arduino. Somebody may ask you, what is the role of this? Why are we having different probably components here and there? Great. So I think maybe it is good today that we have a look at the other thing, and then of course we want to go ahead and plug. What about if we plug our board in the probably, I don't know whether we are still getting echo. Napua is saying we are getting echo. I don't know whether the echo is still on. Is there anybody who is getting echo and has joined? Or maybe it is done. I think maybe that was a message that a while ago there was some echo. We have rectified it. Thank you so much. So we need to go ahead and plug in our board to our computer. But before we do that, I think there's quite a number of things that I want us to look at and read about what else is there to be used, because it's not just a matter of taking the board and plugging it to the computer and now you start programming, but we'll be asking ourselves, what are we programming? What is this that we want to work on? So this is always the thinking, that whenever you get the board, now it's straight away you go plug it into the computer. But I think it is good to look at the whole kit. What else are available? When you go to the market, in most cases, you'll find yourself buying a kit. We don't recommend that you buy only the board itself at this particular level, because you are being a beginner. You'll be interested that you want to get a starter kit. And in most cases, this one comes with very basic kind of components that can allow you and help you come up with basic programs or basic projects. But some of those projects are not even basic. They are equally good and they can really work very well. In the kit, they come in different sizes. They can come as a plastic, they can come probably in boxes, in kind of packages, but all in all, they contain, of course, just almost the same kind of components that we are going to look at them through and through. There's a link here which I'm just putting. If you go to Arduino CC at the home page, you're able to see what are some of the components that comes with the kit. What are these components that comes with the kit? And some of them are written here. There will be a push button. Maybe in your project you want to do something around a push button. And this is the front. Of course, this is the below, how it looks like. There will be a servo motor. Maybe you want to do something that only opens the doors and closes the door. So you need some sort of a motor or some sort of a moving part like that of servo. Then there's potentiometer. Potentiometer, of course, is for adding or increasing voltage or stuff like that. And this is quite very analog because it's not about on and off. It's about increasing it in range. Maybe it's a range of 1 to 2. So where is the volume? Like whenever you're adding volume for music, definitely it is a range. It's not loud and quiet. If it is on and off, then the music will not be as enjoyable. You must take it through a range. And the range here is done majorly. You'll find in most of those spaces, or rather in the radio, you'll find the potentiometer is very, very key. It's the one that you take and twist as you increase the volume. It's just merely a potentiometer. So most of these components are found. And then we have here the LED. We were talking about LED yesterday, whatever light emitting diode. In brief, it's called LED. And we have different colors. We have the yellow, the red, the blue. It depends, and I'll be able to show you some of the colors we have with us here today. And I think maybe it's not bad to also add. And I don't know how the echo will be able to do because I just don't know how this. I have some machine here that I think the echo is there. I think I'll just use it for quite a little, and then we stop it. So probably if you can look at the side video, which we are now having closer look, and you can see the different colors of the very okay. Let me just speak that quickly, and then we can get back right. So probably. So yeah, so you can see some of the kits that we have here. They have different colors, and the colors are these are just LEDs and stuff. Like if at all maybe you're not able to see, this is colorless, and then of course they are the red, and then you can see that is red. And then I want to give you the green one. You can see that is green. There are different colors, and it all depends on what you want to do. All right. Let me put you back. Great. So when we talk about the kit, definitely it's very important you learn about the kit in full. They are different. And I think maybe already in the schools we are having these kits. If they are not there, definitely they are going to be bought very soon. And you'll get different components inside. Today we wanted to go through some of the components. We'll not be able to completely exhaust the components, but it's good that we learn something about the components very quickly. Great. Some of the components, I think I've already mentioned some of them. LED, light emitting diode, you'll see them like this. There'll be a photoresistor, especially when you want to do projects that senses. These are always called sensors. Majority you'll find sensors. And then we have probably, let me begin with this at the side before getting to the side of the sensors. The jumper wires will really be able to be very key, especially when you'll be connecting your projects. You'll need wires, and they're of different colors that you may need, especially if you are probably using maybe colors, and then probably you would want again another blue color to go somewhere. So you will need different colors of these jumper wires. Then we have the resistor. The resistor are always very important because the resistor will always prevent components from really burning quickly. Because, for example, the LEDs may not be able to take the 5 volts. Remember, we talked about the 5 volts, that the output of the pins. The pins may be able to get you probably the output of 5 volts, and 5 volts are just too much. They cannot work with these particular LEDs. So these LEDs may not take up to that level. So if you just connect them directly to these 5 volts, definitely they will just burn. So in order not to burn them, you'll need resistors. The The resistors come in various sizes. There's 330 ohms, and then we have 10,000 or rather 10K, 330 ohms and then 10K ohms. These are probably, depending on your project, you'll want to decide how far do you want to reduce the power so that you protect some of the components that you're using. We've talked about potentiometer because you see it's moving from 1 all the way to 3. So it is a whole range. So maybe it's going, increasing until it's so loud. When you're adding, probably you're putting music loud, you'll need to move around that. Then we have the diode. And then let me just take you briefly to the photo. From the sensor side, we have photoresistor. I think this one particularly is basically a sensor that senses that there is light. So when you want to do something that's really very sensitive to light, you use photoresistor. Maybe your project is focused on light sensitivity, so you think about photoresistor. Maybe your project is about piezo. This one is basically for getting sound. The buzzer, probably you want just the sound to come out, so you'll be able to use this. Then we have the transistor, the temperature sensor. Probably yours is about the temperature. Then we have the motor, the DC motor. You want to make maybe some circle, or probably you want some movement in probably you have a project that requires that the car has to move from one place to the other. When the car moves, definitely you need the tires or the wheel to go around and to move. And in this particular case, definitely you'll want to have a DC motor, definitely. Push button, of course, turning on and off components in your project in case your project requires that. We are still just going on by exploring what we have, and I'd want to welcome more of your questions as we move on. It is important you ask questions, that one, and give feedback also, because it is important we know that we are really helping you understand these things. I want to talk about, again, another component, another part of Arduino, which is very important, and it's called Arduino Shield. Remember, as we talked about Arduino last time, we said that all your projects may not be handled by Arduino as it is. And sometimes you need either to extend it or to get a different kind of Arduino, or to look, how do you really ensure that you maybe we can say you upgrade the capability of Arduino. You do that with components which are called shields. So Arduino Shield, probably you want to do something with for example, Wi-Fi. You need a Wi-Fi component because Arduino does not come with a Wi-Fi component. So if your project really needs a Wi-Fi connection and stuff like that, you will need to have, you must be able to extend the capability of the Arduino to be able to capture the need you are looking for. And that's why the shields are there. They come in various shapes, and these are just some of them. We'll continue looking at more. There's this we're calling PCB shield. There is also the built shield, inserted shield. Of course, there are those shields that can be probably just inserted, and we'll show you, because for example, if you look at this very keenly, I think here I wanted to talk about one, the kind of shield. How do we connect to the Arduino board? This is why I've put these three categories of shield. So there are those shields that when they come, you'll find they have small holes. These small holes are the ones you use to connect them to Arduino, because you will use this particular gadgets. You'll find that this extension pins, you'll find them all in all the kit. You'll always find that, and you can cut them. They are very long. I think I'll show you in our kit. I've just seen them here, and you use them now to connect that particular shield or an extension. It's a way of extending the capability of your Arduino. Then there are those ones that are already built. Probably you'll find some Arduino boards will come when they already have this part. You'll find it has a joystick sort of for driving. If at all it's game, you're pushing it down or this way or this way or that way, you know, forward, backward, the way you push it, like this probably. So and again to the south like that. So you'll find most of these built, they're already built in an Arduino board. So you can buy a board that already has the shield built in them. So ensure you look at that, look at them like that. Or you may not be able even to find how you can connect. So it is upon you to either ban or rather connect some of these links or the endpoints or the connections. You try and now get cables, solder them here, and then connect them back to the Arduino board. So be able to use such a shield. So remember, shield we have talked about is just they are just more components that you can use in order to increase the power or the capability of your Arduino. Great. I think that is great. I'll be giving you 2 minutes to keep asking questions, and I want yes, somebody's asking how does a resistor work. Continue asking questions. We'll be working on that very shortly. Then we have the other shields, the type of shields that are just inserted. Then they are inserted. They come with some pins below. What you need to do is just insert them on the Arduino board to be able to extend the capability of the Arduino. And you can see here, down here, this is the Arduino. The Arduino board is just down here. And then this is a shield which has just been fixed. Yeah, you see, when you look keenly between here, you'll find they've just been inserted on top of the Arduino board. And you can see this is the Arduino board. This is the USB, and this is the power for the power, and as we have always talked about it. And the other pins, these are analog pins, you can see. The other pins are the other side. So you'll find this particular kind of board has been inserted on top of Arduino board, meaning probably you want just to dedicate your project and you're aware of what your project is going to do, then you buy the shield just to extend the capability of the board. I think maybe I want to show you more shield. It can be a shield that wants you to use micro SD. Probably in your project you want to use a micro SD to maybe it's about video or playing music. You want to come up with a project that is playing music automatically, and therefore you will need an extension, because on the board, Arduino board, you will not find this space for you to insert the micro SD. As you can see, the space is somewhere here. I hope you'll be able to see. That is where you'll be able to fix the small SD. So this one is not coming with Arduino, and you have to buy a shield on that. Then we have MP3 trigger, definitely again still for the music. Maybe the MP3 is already put inside and probably can use it as memory. We have the LCD. This one you'll always see it come. It will come with the LCD. We're calling about liquid crystal display. So for you to be able to see, to read from whatever you are writing, maybe you want it to display the temperature, you want it to display any word or welcome home, type your name, and people are able to type. So you want them to have this screen. So this screen may not be very easy for you to connect it to Arduino, because the screen itself has so many pins, and I'll be able to show you in a live one that it has so many pins, and it becomes sometimes very hectic to connect it to the Arduino board, because with so many small pins below it, it's so hard. Even for me, I found a lot of challenge trying to connect the screen to the board. So we have this. That's why we have now this other thing. You can see the board that the screen is sitting on. This board is a shield. So you have now very few pins. You see, you only have very few pins here. These are the pins that now you are going to use to fix. So these are the ones you're going to fix on the board. So it's very easy, you know, just go straight to the board and fix that, and your screen will be working. Unlike when you want to connect the whole screen to the Arduino board. So it is the shields are very important. They help the work become easier and extend the capability of the Arduino. The other shield, again, I'll just move through very quickly, and probably maybe let me just show you probably a work about how a shield can really help you. This is the Arduino. I think we've talked about the Arduino. This is the Arduino here. Probably there's a sensor. In your project, you have an Arduino and there's a sensor. And then, sorry, this is not the Arduino. This is the Wi-Fi shield, because we have the Ethernet for you to put the internet cable here. This is the Ethernet port. So definitely, because Arduino, this is our Arduino, sorry. This is the Arduino, and you see the Arduino does not come with that port. This port, you cannot find it in the Arduino, the Ethernet port, so that you put the internet cable. Maybe you are connected to the local area network. Your internet is connected via wire, and you want the cable to be fixed to your Arduino for your project, maybe to connect to the internet. So probably you are having a sensor or somewhere, and this sensor maybe is speaking, as I look at it, is more of a temperature sensor. It is speaking some temperature, and you want that temperature get to the Arduino board. The board picks the data, and then to push it to the internet. The internet is here indicated by the cloud here. So what do you do? How do you take the data from the temperature through the Arduino board to the internet? You will need an Ethernet, an Arduino Ethernet shield or Wi-Fi. It comes Ethernet or Wi-Fi. It comes with Wi-Fi together. So this is, and even comes with, look, there's even a small space here for you to be able to put in a SIM card. You can even put your SIM card there so that you use the data bundle to still run your project. Using the data bundle, you're able to push this information on the cloud or rather into the internet, and take them to probably a data storage service somewhere, or even have them presented in the computer in your Excel or any other data visualization, whatever software that you have. So it is important to know that a shield is very important. When you want to do your project, you'll want to have probably another shield to add the capability of Arduino to be able to focus more on your project. And this is in response to the question that somebody asked, what does it mean if you want to do a project, we have to buy a specific Arduino? Maybe not really. It's not important you buy a specific Arduino. You can just get the same Arduino, but move ahead and try and get something else like the shield to extend the capability of that Arduino. I think maybe that is very clear, and I've now shown you an example. So very quickly on other shields that exist, we may not be able to exhaust all of them. I think I'm just repeating the same thing. These are just the same thing, that the shield can be Wi-Fi or Ethernet. The shields come in two. There's the Wi-Fi shield or the Ethernet shield. And remember the Ethernet because of the Ethernet cable. I'm just trying to explain more on that. I think this is more elaborative. Then there's micro SD, either to carry the data, or even it can be a SIM card to be able to connect to the various networks, the telephone network, telecommunication networks, be it Safaricom or Airtel. You put it there, and you are able to push your data online, or even to call somebody. So maybe it is about calling and you need this kind of shield. So maybe there's another shield towards that, which I'll be showing you. But in most cases, I think this is about micro SD. Definitely it's about storing data more than, or photos. Probably you're putting a security gadget somewhere and you want those photos to be sent to your phone, as it shows probably who is coming at the door. And then as they come at the door, the camera takes the photo, and then the photo is sent straight to your phone using, so definitely you'll need a place to store the photos. Maybe not sent to your phone, maybe you'll come later in the evening remove the SD, take to the computer, download the photos, and see what really happened during the whole day. In most cases, remember, we have such. So it is very important to understand that an Arduino board can be extended, the capability can be extended if we add in some of these shields. Now the shields come in many formats. There are these shields, you can see more. There's even probably a screen here, an LCD, there's a screen. Maybe you need a screen and therefore you don't have the screen. And even connecting this screen to the Arduino can be a very uphill task. But if you have a shield that has already connected it, so yours is just to connect direct, it is a bit easier for you. And I think you can see others already mounted, like this one here. And then this is a GPS shield. It's written even on the board. The GPS shield is just for location. Maybe you are doing something and you want it to show location. Probably you have put most of this Arduino in different locations and they're monitoring animals in the forest, for example. So the one that really monitors an animal is able to send the location coordinates, and you're able to know that that thing is happening in this particular location. So in order not to suffer so much, we have this shield, which is already, you can see it is plugged on top of the Arduino. Arduino is, of course, the one down, and this on top, the one on top here is basically the Arduino, the shield that is probably moving and taking to the next level. I think more shields are here. You can see the touch screen shield. Probably your project has a touch screen part of it, so you need a touch screen shield. There's the wave shield. There is the data logging shield. And look at the way some of them really require a power source on their own power source. So don't think that you're going to use the power from the Arduino to power some of these shields. So they need the power source. But still, even with all these shields, you will still need an Arduino. Remember that these are just shields. They are extending the powers of Arduino to be able to come up with your project. XB shield, Ethernet shield we have talked about, Wi-Fi shield I think we have talked about. There are quite a number, and it is important to know that you will need most of these shields in different work, and they're going to help you in your project. I think maybe I want to take a break, and during the break I want you to ask questions, especially based on what we've talked about. Then we'll go straight to the other modules that are found inside the kit. These are not necessarily shields, but they are just modules and components that are used for Arduino. 3 minutes for questions, and it will be good. If you don't have time to get question, kindly, you will definitely type in the question, and in our next session, I will be able to answer all the questions, even the ones that you've typed today. Now we are back, and we are talking about the modules that you'll be able to find. Some of these modules, they come in the kit. If you don't get them in the kit, probably you may be able to look for them in the stores on the market where you can be able to buy them in the shops. The GPS module is here. The Bluetooth module, probably you want to run, maybe your project is about Bluetooth, or maybe you want to use the location. You want to look at the sensor. These are mostly the temperature sensor and humidity. This one picks the temperature and humidity at the same time. How wet is the environment? The RFID module, probably for, in most cases, you're looking at those entrance and access, and you need to get those modules depending on your project. And we'll take you through all these one by one as we move on. The sensors and the modules, we're still continuing. There's even the gas sensor, and they come in various sense. For what project can you do with a gas sensor? Probably detecting fire. When there is fire, and you want to really, you can put it so that it detects fire or smoke. Like we can say, do not probably smoke here. And then you put this, you'll find in most cases where they say smoke should not probably, people should not smoke. So these sensors are put there to detect people who are smoking, and it's able to report them. The temperature sensor we've talked about, and of course the flex sensor is here. Then think about the fingerprint scanner. I think you have had such cases where you even register or go to school and you're told put your fingers here. These scanners, all those projects were done, and they're very cheap. I think the fingerprint scanner, I think, should be costing roughly 200 shillings and stuff like that. So you just pick this and add it to your project. Then there's the counter. You can always use this, especially when people are passing. You can know how many people have passed and stuff like that. Think about other sensors, and I'm adding more sensors here. I think maybe, yeah, I can recognize the other different, the photoresistor is here, probably infrared is here, and then of course the force sensitive. If you want to deal with earthquake detectors, you want to come up with an earthquake detector, probably you want to really reduce Hall effect and stuff like that. Start thinking around the sensors. What your project, where will it be taking you? And then more components that you can get. Remember, we are talking about the Arduino Kit. If you can remember, we are talking about the kit, and these are some of the sensors you need to look, the components that you look out in the kit. There is a relay. I think we've not talked about relay. Maybe relay mostly is used in projects where you are switching. It's a switch driven by a small, used to control larger voltage. You can put it even to control power in the house, so that when you're away, it turns off the power. Or sometimes you see something like you put a light, movement. We have movement sensor. You put it in the toilet, because mostly, or the dormitories, you find in the dormitories, the lights are only left, or the classes are always left, and we always complain, who did not switch on the light? Who did not switch off the light? So in such a case, you just put a movement sensor and you connect it to a relay, so that when there's nobody totally in the room and people have moved out completely, then the lights are turned off automatically. So you don't have to blame anybody, not even the leader, the student leader, who is supposed to be in charge of the classroom or the lighting and stuff like that. So think about all this. We will share, and then you'll be able to know where do we come with. And these are the components. You'll be able to find them in the kit. More components. The kit, we talked about jumper wire, we talked about potentiometer, LED. I think there's a lot we can probably practice here. There are more components, of course. Photoresistor, then I think all this we've talked about. The motor, yes, motor is for driving wheels, or probably want to drive something across. You need the motor, something like that. Think about those. I think we've talked about all that. So all these ones come inside the components. They're the ones that come with the Arduino Kit. I'll want to take 5 minutes to talk about the board. This is a very important thing, and it's one of the components you'll find in the kit. The board comes in various sizes. There's a full board, then there is a half board, and then there's a very small quarter board. This one is usually they are all used in different, they all do almost similar work. Of course, the full board enables you to connect many components, and you're able to reach it, how you need to be able to connect so many components from it. And then we have the half board. This one also connects to the various components. And then we have this small other board. So you may look at this and think maybe it's not a board. For the first time when I looked at it, I dismissed. I said, what is this? not knowing it was just one of the boards that they also come with the kit. Remember, there's one thing you have to also know about the full board. Some of the full boards, they are not fully connected. You'll find it's a full board, but halfway, it's this component here, because we are expecting that in a board, the whole of this should be able to be connected all through up to here. And this other section also should be connected all the way to the other side. But you'll find that in a board, some of the boards, this is not the case. They are full board, but they are not that connected. So you have to be careful of the kind of board you have in your kit. When you receive the kit, also make sure that these ones are connected. You'll find that these ones are this are the sections written plus and minus. They are all connected all through. There's a continuous connection below it, or rather inside, that connects these points to this point here. Okay. Then this other side also are also fully connected all through. But then these other ones in the middle here, they are only connected in this way. And I think we'll be able to show you that in the next whatever. And you can see what I'm talking about. You can see here, this connection is full all the way. I mean, it's straight. Sorry for the line. It's straight all the way. I may not be able to draw this given that I'm using the mouse, but you can see. And these other ones are connected like this. So if you connect something here and expect it to be connected with something you have connected here, definitely you won't get it right, because this and this are not connected at all. And it's very important you know that. That connection is what makes it possible. So some of the boards will come when they're a bit transparent like this, but you'll find most of them, or rather, if you are able to break the board into pieces, you'll find this kind of connection inside. There is like a small metallic thing, or iron, or a sheet that is connecting inside, just to show you that there is a connection inside. Probably more about the board is that I think this one now the lines are very straight. I was able to manage to draw it, and we call it solderless because you don't need to solder it, to burn it. Remember using soldering bits or soldering wires. You are not supposed. You don't need to burn it so that you are able to get it working. So you can just correct. Right, there are questions here, and I want to really answer them briefly, correct, so that we are able to work with them. And I think that one in the last 5 minutes will be answering some of those questions there. Great. So vertical columns, you can see you can see that kind of connection. So it's important when you have the broad breadboard, you ensure that probably these connections, you don't lose the connection, because there's always possibility that you can lose that connection, and it can be very, very bad if you lose that connection. I think maybe that's the brief. And maybe what else do you want to know about the breadboard? Then look at this breadboard. There is A, B, C, D, like that. So you are able to tell somebody, kindly connect on pin 2B. Pin 2B will be probably this pin over here, because you can see it's 2B. Connect your wire, your jumper wire, on pin 2B or 12E. 12E would be somewhere here. So ensure you're picking the 12 and the E. This one will help you to get this vertical. But remember the kind of connection that we are having. The yellow means a continuous connection. Where there's no yellow, it's not really connected. So it is important. But again, I want to remind you that in the full board, some of the boards you may not be able to get. You may find it is connected halfway. So this yellow, you can fix a wire here, expecting it's connected to a wire here, only to find that they're not connected. So be careful when you're dealing with those full boards. Some of them are not, especially the latest versions that I'm seeing in the market, are not connected at all. Okay. So I think that is very, very important. Right. I think maybe probably the last bit would be to answer the question, but I think just talking about the solder, more explanation about it. I think this one we've talked about. So remember, these ones are not connected at all. Ensure you are looking at this. These ones is there are no connection, and these ones are connected. So the green color I've used here to draw to tell you that these ones are connected and these other ones are not connected. So take care when you're dealing with that kind of a thing. Great. Let me take this opportunity to answer these questions very quickly. Question number one, probably somebody's asking, and let me get it, that we have questions and questions indeed. So let me just publish all of them. Wow. Okay, question number one, Kisi, second, I think Kisiri, what is the work of gas sensor? Gas sensor definitely is to be able to sense where there's gas. Probably you don't want gas leakages in the laboratory, you use it. Or when we are talking about smoking, fire extinguishers or automatic fire alarms, they are made of gas sensor. You use the sensor to be able to bring in, to be able to detect that. Then somebody asked about the flex sensor. Flex sensor, the flex sensor is mostly, of course, as you can hear, the word is flexible. In most cases, as you move around it, either it increases in rate or stuff like that. So in most cases, this one is used when you want to do projects probably around door. As the door opens, the wider it opens, something happens. So it is flexible sensor, and mostly you'll find it is used to in the door sensors mostly, or probably even I've seen it in most cases. Some of them put on animals, and you see if it is becoming a bit stiffer, then you realize, hey, the animal is going to get choked. So you try and loosen it. So it is more of just looking at what's the flexibility of whatever gadget you're dealing with. So I think maybe you can be able to find out by trying it out in your projects, in the upcoming projects. The last question, I think maybe that I did not. How does the resistor work? Of course, it reduces. Resistor only reduces the electricity, or rather the voltage, and enables and makes sure so that the component, by protecting the component from really maybe regulating the amount of maybe voltage or power getting to the component. I'm trying to explain it in a very, very simple way because I know the students, the members are mixed. There are those who are taking physics, there are those who are not taking physics. But all in all, it is used to protect the gadgets from burning so that you only allow that appropriate kind of power to get in. I think all those are the questions that were here. The rest are basically comments. The rest are basically comments. Then probably let us say that tomorrow we'll be continuing from here. The next one we'll be talking more about how to program. I think we'll now basically get settled and we get straight to programming. Probably we'll be talking about how to connect those wires, how to get the different hardware together, and finally probably we'll be talking generally how do we start programming. I think thank you so much for today's session. I've loved it and I've enjoyed it as the way some of you have also enjoyed it. Thank you, and that will be the end of our session today. Thank you so much, and God bless.